So today we're going to be talking about conservation of mechanical energy. This is represented by E equals K plus U. In other words, all the energy in the system is made up of kinetic and potential energy. We can rewrite that equation like this. The x in this equation denotes the distance that we stretch or compress the spring, while K denotes the spring constant in newtons over meters. This is derived through Hooke's law. Let's imagine a little kid bouncing on a pogo stick, and we wanted to find out the maximum height he can jump. Let's start by thinking about the spring in the pogo stick. It starts from an initial position and then compresses to a final position. In any physics problem, it's always good to start off with what you know, and then decide what you need to know. In this case, we know the spring constant, the mass, and the spring compression, and we need to find out the velocity. For our equations, we'll be using this conservation of energy equation from before, as well as a kinematic equation. Now for the fun part, let's do some calculations. We can start with our conservation of energy equation and plug in what we already know. Once you know what equation to use, it's very easy to plug and chug. We were given K, X, M, and we need to solve for V. This equation is helpful when considering conservative forces such as elastic force. Since we have a 1/2 on each side, we can cancel them out just to save us a little bit of time. Now let's bring out the trusty calculator. Now that we have found that V is 3 meters per second, we're going to take a little trip down memory lane and use some kinematic equations to solve for the height. We know that the initial velocity of the pogo stick will be 3 meters per second, and the velocity of the pogo stick at the maximum height will be 0. We can use this information, along with the kinematic equation, to solve for the maximum height. Plug and chug your values, and grab your trusty calculator. So there you have it. The maximum height will be 0.459 meters.